Every computer, from the most basic budget laptop to the world's most powerful workstation, has one key component that defines its power: the CPU. And if you've ever shopped for a computer, you've definitely seen these names: Intel Core i3, i5, i7, and i9. But what do these labels actually mean? How are they different from one another? And more importantly, what does the future of these processors look like in a world that is becoming more and more driven by AI? Today, we're going to break down Intel's famous Core lineup. We'll decode the numbers, understand the technology behind them, and discover how these tiny silicon marvels are evolving to meet the needs of tomorrow's technology. Stick around, because this is the ultimate guide to understanding the heart of your computer. Let's start with the basics. The Core series is Intel's main family of processors. The workhorses you'll find in most laptops and desktop computers. Each model number i3, i5, i7, and i9 represents a different tier of performance, kind of like different engine sizes in a car. The Core i3 is your entry-level chip. It's designed for everyday users, perfect for things like browsing the web, using Microsoft Office, streaming your favorite shows, and handling other basic tasks smoothly. It's reliable and gets the job done without breaking the bank. Next up, the Core i5. This is the mid-range champion and probably the most popular choice for a reason. It's the sweet spot for many people, ideal for multitasking, enjoying some light to moderate gaming, and powering through your daily productivity work. It's a fantastic all-rounder. Then we have the Core i7, which takes things up a significant notch. This processor is optimized for content creators, serious gamers, and professionals who need more horsepower for demanding software. If your workflow involves video editing, complex spreadsheets, or high-end gaming, the i7 is where you start looking. And at the very top of the stack is the Core i9. This is the flagship, the absolute powerhouse built for extreme performance. We're talking professional 3D rendering, elite-level gaming and streaming, complex scientific simulations, and heavy AI workloads. The i9 is for those who refuse to compromise on speed. So, in short, the higher the number, the more powerful the processor, especially when it comes to multitasking and handling complex tasks. But what makes them more powerful? It all comes down to cores, threads, and clock speed. Every core processor contains multiple cores. Think of these as individual brains, each one capable of processing instructions. The more cores you have, the more tasks your computer can handle simultaneously without slowing down. But it doesn't stop there. We also have threads, which are virtual components that help manage the tasks being sent to the cores. Thanks to a technology called hyperthreading, a single physical core can often handle 2 threads at once, essentially doubling its multitasking capability. Let's put this into perspective. A modern Core i3 might have 4 cores and 8 threads. A Core i5 could step that up to 6 cores and 12 threads. A Core i7 often jumps to 8 cores and 16 threads. And the top-tier Core i9? The latest generations can pack an incredible 24 cores and 32 threads. When you pair this with another clever feature called Turbo Boost, which dynamically increases the processor's clock speed when it senses a heavy workload, you get a CPU that's both powerful and efficient. It runs cool and quiet for simple tasks, but ramps up instantly when you need that raw power. Now, it's not just about the high number. You'll also hear people talk about generations. Intel's core processors are constantly evolving. We started with the first gen, codenamed Nalem, over a decade ago. Today, we're well into the 14th generation, with architectures like Meteor Lake. Each new generation brings significant improvements in efficiency, speed, and power management. A huge part of this progress is due to refining the manufacturing process, shrinking the transistors on the chip from 14 nanometers down to 7 nanometers and even smaller. Smaller transistors mean the chip can be faster, run cooler, and use less electricity. But modern Intel chips are more than just raw processing power. They now include specialized hardware for AI acceleration, powerful integrated graphics that can handle casual gaming and 4K video playback, and a clever hybrid architecture. This hybrid design combines high-performance P-cores for demanding tasks with energy-efficient E-cores for background processes, giving you the best of both worlds, peak power when you need it and excellent battery life when you don't. So, let us visualize this with a simple performance comparison to help you choose the right one for your needs. If you're a student or have a home office for everyday tasks like email, web browsing, and word processing, a Core i3 is a perfect, cost-effective choice. It provides a smooth and responsive experience for all the basics. If your life involves a mix of work, multitasking, and some gaming, the Core i5 is your go-to. It handles everything from large spreadsheets and multiple browser tabs to popular games with ease. It's the work and play sweet spot for professionals, content creators, and dedicated gamers who are running demanding applications like Adobe Premiere, AutoCAD, or the latest AAA titles. The Core i7 is the right tool for the job. Its higher core count provides a serious boost for those intensive workloads. And finally, for the true power users, AI developers, 3D artists rendering complex scenes, or hardcore gamers streaming in 4K, the Core i9 is the ultimate choice. It is built for those who push their systems to the absolute limit and demand nothing less than extreme performance. But what about the future? Where are these processors headed? The future of CPUs isn't just about getting faster, it's about getting smarter. Intel is deeply focused on integrating artificial intelligence directly into its chips. This will enable powerful on-device machine learning, dramatically better battery life, and advanced computing capabilities that don't rely on the cloud in the near future. We can expect to see integrated neural processing units, or NPUs, become standard. These are dedicated AI engines designed to accelerate tasks like real-time language translation, image enhancement, and predictive analytics. We'll also see even smarter energy management for laptops that last days, not hours, and new quantum-inspired designs that could revolutionize computing efficiency. This innovation isn't happening in a vacuum. Fierce competition from rivals like AMD and ARM is pushing the pace of development faster than ever before. The coming years will likely bring us truly adaptive CPUs that automatically and seamlessly optimize themselves for whatever you're doing, whether it's editing a video, playing a game, or writing code, all without you having to lift a finger. From the humble Core i3 to the mighty Core i9, Intel has spent decades defining what performance means for every type of user imaginable. And as the world of computing shifts towards AI, edge devices, and deep cloud integration, these processors will continue to evolve far beyond just simple speed. They're becoming smarter, more efficient, and more interconnected, creating a powerful bridge between human creativity and machine intelligence. So the next time you see a sticker for a Core i3, i5, i7, or i9, remember it's not just a number. It's the story of computing's evolution, and it's a glimpse into the incredible digital future that's powering your world. Thanks so much for watching. If you found this breakdown helpful, please hit that like button. And consider subscribing for more tech deep dives. Let us know in the comments which processor you're using. See you in the next one.